Hey everybody, Mr. Piercy here, and what we're going to be looking at today are how we identify some properties of parallelograms. So if you're going to kind of follow along with the investigation that we're going to be performing today, you'll need some blank notebook paper or just blank printer paper, whatever you have handy, and a something to make a straight edge with, a compass and a pencil, and preferably a piece of tracing paper or patty paper. Now, in the past, I've demonstrated how to construct parallel lines, but for the purpose of this investigation, I'm going to cheat just a little bit, and I'm going to use the two sides of my straight edge to draw a set of parallel lines. Okay, so we have that. Now the next thing I'm going to do is I'm going to kind of use my compass to create a quadrilateral, because a parallelogram is a quadrilateral. So what we're going to do is I'm going to just kind of pick some spot here, and I'm going to just use the endpoints of my line segment here. And what I'm going to do is I'm going to pick a spot and I'm going to open up my compass somewhere past the width of the other line. Okay, and what I'm going to do is I'll just kind of make a mark like that, and I'm going to make another one over here, but I need to kind of extend my line up here out a little bit further so I can see where they intersect. And what I can do now is, from the intersection I made with the arc and the line, I can kind of create something that looks like this. So I'm going to call this quadrilateral A, B, C, D. And before we go too much further here, we're going to kind of trace this quadrilateral on our patty paper, because we're going to use the patty paper to help us verify some things on the figure without necessarily having to spend a lot of time measuring them. And the fact that if you're following along doing this on your own, odds are the parallelogram that you construct and the parallelogram that I construct are not going to be the same, which is fine. In fact, that's actually encouraged, because as if you and I have different shapes, meaning that they're not congruent, but the properties that we see are the same in your figure and my figure, then that's a pretty solid indication that it would be true for all figures that are parallelograms. Now, the definition of a parallelogram is that the opposite sides are parallel. Now, I constructed AB to be parallel to CD. That's what we just cheated a little bit and used the opposite sides of the ruler. And then I used the compass to construct segment BC and segment AD. Well, what the patty paper is going to allow me to do is I'm going to just translate the patty paper, and I'm going to place segment AD on top of segment BC. And when I do, I can see that those two segments are the same. Well, what if I compare the other set of opposite sides? If I compare AB to CD, well, we see that those are the same also. So one of the properties about parallelograms is obviously the opposite sides they're parallel to each other. But not only are they parallel to each other, but they're congruent to each other also. They're parallel and congruent to each other. Hence the name parallelogram. That's kind of the unique thing about it. Okay, now there's another thing that we can look at here that's something that's unique about parallelograms. Well, look here. Again, I'm going to use the tracing paper for what I have. And what I'm going to do is I'm going to take the patty paper and I'm going to spin it 180 degrees. So that way I can put the opposite angles together. I'm going to put B with D and A with C. And when I do, we can, again, just kind of quickly measure. We're not actually measuring it, but we're just comparing the angles. And I can see that angle A and angle C are the same, and angle B and angle D are the same. So one of the other characteristics about parallelograms is that the opposite angles they're congruent to each other. Alright, so let me put the patty paper back to where we started. Well, this next part, I'm still going to look at the angles, and this next part really isn't, really shouldn't be anything brand new to us. Because I have parallel lines here and here, what we know is that since AB and CD are parallel to each other, well, the same side interior angles, AD is acting as a transversal, same thing as BC. So the same side interior angles should be supplementary. So if I take angle A and put it down here at B so that AB is sitting on top of DC, we can see that it does indeed, if I compare the two angles, here's angle D and here's angle A, those two angles are a linear pair, they form a straight line. We can see the same thing on the other side. So here I'm taking B and I'm putting it on top of C, so here's angle C and here's angle B. They are a linear pair. Well, because the opposite side, or because the same side angles are supplementary, that kind of confirms that my lines are parallel. Well, what if I take the patty paper and I move it the other direction? So that way I put angle B and angle A together, and angle C and angle D together. Well, when we do, we again see that the angles form a linear pair. So if A and D, they must be supplementary because A, B, and C, D are parallel. Well, if A and B are supplementary and D and C are supplementary, then that means that AD and BC have to be parallel to each other, which again kind of reinforces the name, the parallelograms. The opposite sides are parallel and congruent. So here we can also say that the same side angles they're supplementary. Now there's one final thing that we're going to kind of look at here, and this is going to require me to add some stuff to my figure. I'm going to draw in, or construct, however you want to think of it, the diagonals of the figure. So I'm going to draw in segment BD, and I'm going to draw in segment AC. And I'm going to put those also on my patty paper here. I don't necessarily have to copy them. I can just draw these in. Oh, keep my finger out of the way. So there's AC and BD. Now, the last thing that we're going to look at here has to deal with the diagonals. So I'm going to call this point E, just to give it some kind of a reference. Okay. Now, let's take our figure, let's take the patty paper and let's turn it 180 degrees. Okay. Now, if we try, or actually let's try and compare the lengths of the diagonals. So here, let me go back to the beginning. what I want to do is I want to compare AC to BD. So what I'm going to do is I'm going to take the figure and I'm going to put those onto each other. And clearly AC is much longer than BD. So the diagonals aren't congruent. However, let's take point A, let's take segment AE and compare it to segment CE. So I'm going to slide the patty paper so that AE is sitting on top of CE, and when I do, I see that those diagonals are, or that those portions of the diagonals are congruent. So we've established that the opposite sides are parallel and congruent, but this diagonal AE and EC, those are the same length. That's what we're seeing in the patty paper. Well, what if I look at DE and BE? If I take segment DE and I put it on BE, I can see that those are the same length also. So 1, 2, 3, 4, 1, 2, 3, 4. What that allows me to conclude is that in a parallelogram, the diagonals bisect each other. So these are the main characteristics that we're going to be looking at about a parallelogram. First of all, the opposite sides are parallel, hence the name parallelogram, and they are congruent. In fact, the only way they can be parallel is if they are congruent to each other. The opposite angles are congruent to each other as well, so angle A is congruent to angle C in my case, and B and D are the same. Now, just real quick, while we're talking about the angles, we've added the diagonals. Do the diagonals bisect the angles? And the easy way of checking this is we can clearly kind of see angle ADE and angle CDE. Those visually don't look anywhere close to be the same. And if I take my patty paper and I fold it so along that ray CB, and I compare the measurements of the angles, they don't line up with each other at all. So the diagonals, they bisect each other, but that's all they do. They don't bisect anything else in a parallelogram. So the same side angles are supplementary, and the diagonals bisect each other. Those are the main characteristics that we're going to be looking at that makes a quadrilateral a parallelogram, or that a parallelogram has. There's two ways you can look at it. If I say I have a parallelogram, then we can conclude these things. If, however, I just say I have a quadrilateral, but I have these things true about it, then I would be able to say it also must be a parallelogram. So that's it for this lesson as far as why something is a parallelogram. If you have any questions about anything, make sure that you send me an email or leave me a comment in the classroom section, and I'll be happy to. We can stop.